Today we are going to continue solving systems of equations. We've solved systems of linear equations, two methods so far. First, we have solved by graphing. So our goal is that I can solve systems of linear equations by 1, graphing. You guys have already done this, but we are continuing to practice this in the homework. 2, yesterday we learned how to solve by substitution. And this is what our focus will be today. There is a third method, and that method is called elimination, but we will not focus on that until later on this week. So, example 1. The direction today is going to always look the same. Solve the system. 12x plus 4y equals 24, and y equals 3. I'd like you to pause the video right now and attempt this on your own. Once you have attempted it on your own, please check your answer with someone in your group and see if they are getting the same answer. Remember, you can always check your solution by substituting in the x and y coordinate into both of the original equations and then making sure you get true statements. Now that you have solved this on your own, I will go ahead and demonstrate how I would choose to solve this. I know that y is equal to 3. So in my solution is going to read something, comma, 3. But I don't know what my x coordinate is. So in my other equation, I will substitute y wherever I see, 3 wherever I see y. When I do that, I get 12x plus 4 times 3 is equal to 24. And now I can solve this equation for x. Well, 4 times 3 is 12, so I have 12x plus 12 equals 24. And now I subtract 12 from both sides. I get 12x equals 12. Divide by 12, and I get x is equal to 1. So that means my solution must be 1, 3. Now, really, before I box that in, I should have checked my answer. I should have seen, okay, well, does that make the statement true? 12 times 1 plus 4 times 3 equals 24. And I can say, well, that's 12 plus 12. Yeah, 12 plus 12 is 24. This is a true statement. When I go into this bottom equation, the only thing I can substitute in for is y. That would just be 3 equals 3, and that's a true statement, so that I know my solution works in both equations. So that looks very similar to what we did yesterday. Let's do another problem that, again, will look very similar to what we did yesterday, but is a little trickier than this last problem we did. Example 2. The directions are the same. I'm not going to rewrite them, but this system, I want you to write the system for it. So I will give you two statements. One, the difference of twice a number x and a number y is 4. Go ahead and write an equation that models, or that would translate this sentence into a mathematical sentence. We'll do the same for this sentence. The number y is 3 less than the product of 8 and the number x. Go ahead and write another equation for this sentence. Pause the video if you need additional time. If you do not need additional time, go ahead and listen carefully as I explain how I got this sentence. Difference, I know, means that I need to do subtraction, and I know that I need to keep the order of what comes next. So twice the number x means that I will do 2 times x. So it's the difference of that and a number y. Well, that means I will have 2x minus y is, that tells me I need an equals, is 4. So that's one equation. The other equation says the number y is, so y is or equals 3 less than something means I need to subtract 3 at the end of it. The product I know is multiplication, 8 and the number x. So the product of 8 and a number x would be 8x. 3 less than that would be minus 3. So here are my two equations. So that's just a little review from the previous unit. So let's restart this. 2x minus minus y equals 4, and then y equals 8x minus 3. So this is a system we're going to solve. We want to figure out what are x and y. So that's the question we're answering. What are x and y? Now we have this system. Talk in your groups and look back at your notes from yesterday and think through, how do we solve this system? Pause the video right now and attempt this on your own. Now that you guys have attempted this on your own, let's take a look at this. When I see this system, I look and I notice that y is already solved for. So I have y all by itself, and that is equal to 8x minus 3, which means y is interchangeable with the expression 8x minus 3. Now I need to substitute that in for y in the other equation. Remember, whenever you substitute, you have to have parentheses. So when I rewrite this top equation, I get 2x minus, and in parentheses, 8x minus 3. And that will be equal to 4. And now I have to solve this equation. Well, I see this number out front, but I don't really see a number. I guess I just see minus and then the parentheses, which that tells me there's really this imaginary 1 here. So I need to distribute a negative 1. So I'll carry this down. This 2x has not changed. Negative 1 times 8x is a minus 8x. Negative 1 times a negative 3 is a positive 3. When I look at this equation now, I see that there are two variables. However, the variables are on the same side of the equal sign, so I can combine like terms. 2x and a negative 8x would be a negative 6x plus 3 equals 4. Subtract 3 from both sides. I get negative 6x equals 1. When I solve, divide by negative 6, divide by negative 6, I get x is equal to negative 1/6. Well, that's what x is, but I also want to figure out what is y. To find y, remember, we have an equation that relates x and y. Now, I could choose the top equation or the bottom. However, the bottom one is going to be a lot faster because y is already solved for. So y equals 8 times negative 1/6 minus 3. Now, these are fractions, and we don't like to deal with fractions, but we can do it. If I put that over 1, 8 over 1 times negative 1 over 6, that'll become a negative 8 over 6. If I simplify this, this becomes negative 4 over 3 minus 3. Now, in order to subtract, I need to have a common denominator if I want to make this a single improper fraction. That's really over 1. So if I multiply by 3 on top and bottom, I get negative 4/3 minus 9/3, which if I subtract the numerators and keep the denominator, I get negative 13/3. This would be an improper fraction. If I wanted my answer as a mixed number, I would get negative 4 and 1/3. If I wanted my answer as a decimal, I can do that. I need to make sure I realize, oh, this will be negative 4.3 repeating, so I have to show that it repeats by putting that line above it. So this is what x is, and this is what y is. Here are my answers. If I wrote my answer like a solution to the system, like I'm used to doing, this would be negative 1/6, comma, negative 13/3. Let's go ahead and try the next problem. Example 3. We have negative 6x plus y equals negative 1, and negative 2x minus 3y equals negative 7. Now when I look at this equation, this looks different than any of the systems we've solved before. So I asked myself, what's different about this? Well, when I look at this, both of these equations are in standard form. In other words, there's no variable that is solved for in either of these. We have x and y on the same side. So this now creates a new step for us. Our first step in solving a system using substitution is that we have to have one of the variables solved for in one of the equations. So far, we've always had that given to us. Now we need to do a little work in order to get that. So when I look at this, I can either solve for this x, this y, this x, or this y. If I were to actually do this, I'd find out that this variable right here, this y in the first equation, is the easiest one to solve for. And the reason why is that we don't see a number there. In other words, the coefficient of y is 1 here. So all I have to do to solve for y in this equation is to add 6x to both sides. At that point, I have y all by itself. If I tried to solve for x here, I'd be subtracting y and dividing by -6. And the same thing for either one of these. I'd have to subtract or add and then also divide. So we'll draw a little arrow. We want to solve for this variable because it has a coefficient of 1. In other words, you don't see a number in front. So if I take this and I add 6x to both sides, that now adds to be 0. So let's take this down here. I'd have y equals, over here, I'd have 6x minus 1. Now that I've used that, I'm going to go ahead and cross out this equation. I now have this equation and this equation. And now it looks exactly like it did before when we were solving these other systems. Go ahead and pause the video and solve this on your own now. Now that you have attempted this on your own, let's talk through it. We have y is equal to 6x minus 1. So I'm going to substitute this in for y in the other equation because y is what is solved for. Negative 2x minus 3, I take out that y, I replace it with 6x minus 1, and I have that equal to -7, and I can solve from here. I distribute the -3, I get negative 2x minus 18x plus 3 equals -7, and again, noticing my variables are on the same side of the equal sign, I can go ahead and combine like terms and continue solving from here. When I do that, I get x equals 1/2 or 0.5. Be careful. A lot of people will want to tell me that negative 10 divided by -20 is a 2. That's because we're used to integers. We're comfortable with integers. But it is actually a decimal. Now, once we know what x is, you know you're not done because you know your answer will look like x, comma, y. We know x. We can substitute in for y. This is where you actually have additional options now. You can substitute into the original equation, either one of them, or you can substitute in here. I'm going to choose to substitute in here because this already has y solved for, and we found out yesterday that was much easier to solve for y if we already have the equation solved for y. So now when I substitute back in, 6 times 0.5 is, well, half of 6 is just 3. So I get y equals 2. So I have 0.5 comma 2. And again, I can always check my work. So if I wanted to check, I check back in the original equation, -6 times 0.5 plus 2. Does that equal -1? Well, this would be -3 plus 2. And yes, -1 does equal -1. I also have to check in the second original equation, I should say. 0.5 minus 3 times y is 2. Does that equal -7? Well, that would be -1 minus 6. Yep. -7 equals -7. I am good to go. Let's go ahead and try another problem. We're going to try and get through as many problems as we can. If you don't get through all of these, you can always look through this on the course website or practice in your homework. So the directions here again are solve, and we're going to solve using substitution. And when you look at these equations, you'll see again that these equations do not have either variable solved for yet. So when I look at this, my go-to is always the one that has the variable with a coefficient of 1. So look at this right now and circle the variable that you would like to solve for. The variable I would solve for is this guy right here. The reason is that its coefficient is 1. The only thing I have to do to solve for x here is subtract 3y. When I do that, I'll be left with x equals, that's just negative 3y plus 1. So now, I'll cross that out because I've used it. Now, x is equal to negative 3y plus 1. I will substitute that in for x in this equation right here. Go ahead and continue solving and pause the video at any point if you find it helpful. Negative 3 times, well, that's negative 3y plus 1. I want to know what is y then if that's equal to 3y minus 15. And again, I'll continue solving. I distribute the negative 3. I get 9y minus 3 equals 3y minus 15. Now I notice I have two variables, but they are in different sides of the equal sign. So I have to think through, well, how do I solve that? Well, I need to subtract 3y, or I need to subtract 9y from both sides to get the variables to the same side. I chose to subtract 3y because I know 9 minus 3 is still a positive number, and I like to deal with positive integers if I can. So that's 6y minus 3 equals negative 15. Now I have my variables in one spot. I can go ahead and solve from here. I get that y is equal to negative 2, which is great. I'm halfway done. My solution I know will be something comma negative 2, but I need to figure out what that x is. Well, to do that I can substitute in, and I'm going to choose to substitute into this equation because x is already solved for. So x equals negative 3. I'm going to replace the y with negative 2, and now I simplify. X is 7. Before I box in my answers, I want to check my work. I'm going to check this using mental math. Up here, I would have 7 plus 3 times negative 2. Well, 3 times negative 2 is negative 6. 7 plus negative 6 is 1. Yep, that one would work. Over here, negative 3 times 7 would be negative 21. So I'm keeping negative 21 in my head. Negative 2 times 3 would be negative 6. Negative 6 minus 15 would be negative 21. Yep. Negative 21 equals negative 21. There you go. You can use your calculator, you can use mental math, or if you'd like to, you can write it all out. There are 2 more problems that I'm going to go through, and we'll see if we have time to get through all of them in class. And again, if not, there's always the website that you can access. Example 5. Negative 4x plus y equals 6. Negative 5x minus y equals 21. Go ahead and try and solve the system on your own right now. Pause the video to give yourself some time. Now that you've attempted this on your own, let's talk through it. When I look at this, I actually have a couple options here. I could solve for this variable y because it has a coefficient of 1. This y also wouldn't be that bad to solve for, but I would have to deal with some negatives by dividing by that negative 1, so I'm going to go ahead and solve for this y. The only thing I have to do here is add 4x to both sides. So when I do that, I'll end up getting y equals 4x plus 6, and now I've used that equation. So now I'm dealing with this system. Excuse me. Because y is equal to 4x plus 6, I can replace this y with 4x plus 6. When I do that, I get negative 5x minus, again, remembering my parentheses, I substitute in 21. Remember, this is just like distributing the negative 1, so that's negative 5x minus 4x minus 6 equals 21. I have 2 variables, but they're on the same side, so I can combine like terms and get negative 9x minus 6 equals 21, and then solve from here. I get x is a negative 3, which means my solution will be negative 3 comma something, but I got to figure out what that y coordinate is. I'm going to go back and substitute into this equation because y is already solved for, and find out what y is. I get y is negative 6. Again, I would check my solutions in both of these. I'll find out that, yay, we did it correctly. All right, last problem that we're going to do in these notes, example 6. (3x minus 8y equals 24). Negative 5x plus y equals negative 3. Well, I'm looking at this. And again, pause this in order to attempt it on your own. Press play once you've already attempted it. All right, so you've tried this on your own now. When I look at this, this has a 3 as a coefficient, this y has a negative 8 as its coefficient, x has a negative 5 as its coefficient, but this coefficient is 1. I don't see a number in front of it, so that's going to be the one I want to solve for. Add 5x to both sides of that equal sign, and I will have y solved for. So y is equal to 5x minus 3. I've used this equation, so I'm going to cross it out, and I'm going to substitute this in for y in the other equation. So I have 3x minus 8. I take out that y, and I replace it with 5x minus 3 equals 24. And now I'm good to go. If you want to pause at this point to continue practicing on your own, go ahead and do that. If you've already finished it, go ahead and watch the video to see if you got the correct answer. 3x, well, negative 8 times 5x would be a negative 40x. Negative 8 times negative 3 is a positive 24. Be careful of your signs here. And again, two variables, but they're on the same side, so I'll combine like terms. Negative 37x plus 24 equals 24. And now when I solve, oh my goodness, I see negative 37x equals 0. Well, that's okay. I can divide by negative 37, and if you punch that in your calculator, you'll see that you do get x equals 0, and that's okay. Which means I know my solution will be 0 comma something. I just got to find out the y coordinate. Well, let's go back to this equation because it's already solved for y. Y equals 5 times 0 minus 3. Well, that's just 0 minus 3, which is negative 3. So my solution, 0 comma negative 3. If you guys have questions, you can look online at Khan Academy. They do a great job explaining that as well. And we'll continue practicing this tomorrow. Remember that your quiz is on Thursday of this week, so make sure that you are doing the homework each night. Your homework tonight, page 439, numbers 3, 5, 6, 8, 9, and 13. You do not need graphing paper for tonight's homework. Good luck!